Well, hello everyone. This is KP the Math G, and I am here to. I'm just delighted to be here with you and to share with you another AP calculus problem. This is from the 2026 free response question number 6, part C. There are two ways to work this problem. I'm going to show you the way that I understand it the best. I'm not going to tell you it's not long. I would be lying to you if I told you that. But there are no shortcuts in some of this work, as you well know. And so here we go. Part C. Let h be a differential function. This means such that. I learned that a long time ago. Such that h at 0 is equal to 10. And h prime at x equals f prime at 3x. Find h at 2. Well, alright. Maybe I tried to put everything in one little spot here. What I'm probably going to do is I'm going to divide this up right about here maybe, because we're going to need every little piece of space we're going to need. We'll have to flip this over. So you're going to have to bear with me just a little bit as we get this going. Well, let's get started. Alright. H prime at x is equal to f prime at 3x. You know, if we there is a fundamental theorem of calculus that says that if we take, let's say from A to B, let's say sometimes x, alright, and sometimes they'll say h prime at t dt. They'll leave it in some kind of different letter other than x. Well, that is a fundamental theorem of the calculus, which says that that's equal to just simply h at x. And that is one, you can call it the fundamental theorem of calculus part 1, or the fundamental theorem of calculus part 2, or whatever. Part A, part B. Doesn't matter. Alright, there it is. And so A is a constant, so we don't throw that in there. We just put the x in place of that t without, so that's what it is. So when you take the or the definite integral of the derivative, it's just that. So my goal is to get it to h at something. H at x. That's what I'm wanting to do. Since we have h prime at x, I'm just going to take the antiderivative of both sides and let's see what happens. So let's do that. And we're not going to even put anything up here. Alright, so h prime at x is equal to, well, what is h prime at x equal to? F prime at 3x dx. Yeah, dx. Now, in AP calculus, you don't need the dx, but it is important to put it there, but needless to say. Alright. This side is just simple. And just get used to this. So just get used to this. This is h at x, which is kind of what I've been wanting. I kind of see I need h at 0, so I just kind of want to get to h at x. But now this is a little different. Okay, so what we got to do here on the side is we're going to let u be equal to 3x. So du is equal to 3, and derivative of 3x is just 3 dx. Yeah, 3 dx. Yeah. Well, we don't want. We just want dx. So we get rid of that by multiplying by 1/3 on both sides. So this divides out, and now we have 1/3 du is equal to dx. That's what we want right here is dx. So all we're doing is we're just putting a 1/3. Now be careful with that. You can't just put f at 3x. Oh, I made that mistake. I'm not gonna lie to you. I forgot to do this right here. You got to do this first. Woo! Get that right. All right, now 1/3. Now you can just say, you still say 3x, but without the prime. But then you got to remember to put that constant of integration there. Okay? So let's flip the board over and write all this down. And remember now, we're looking at h, we're finding h at 2. Alright, so and we know that h at 0 is equal to 10. So let's do that. Ooh, bear with me because I'm going to have to move everything around. I don't have much room in this room, but I love this board. I've been blessed with it. And this little curtain here. Little thing here. Well, that's another story in and of itself. It's kind of a decorative, whatever you want to call it. Let's put what we know here. So we got h at x here, and we're saying that that's equal to 1/3 f at 3x plus c. Now remember we said that h at 0 is equal to 10. And we need to find h at 2. Alright, that's what we're looking for. Alright. Well, I know that h at 0 is equal to 10, so why not just plug a 0 in here? Now, if I plug 0 here, this is the only thing that makes sense to me. F times 3 times 0. This is the only way that made sense to me. And there is another way that's actually shorter. I know, it's shorter. Maybe on another video I'll show that one as well. This is cool. H at 0. H at 0. Well now. Oh my. F 3 times 0 is 0. Well, we know that h at 0 is 10. Got that. Now, where are we going to find f at 0? Man, oh man. Alright, so I'm just going to show you a little piece of it. X, f at x. I don't think I'm going to need f prime at x. X at 0, f at x. F at 0 is -1. So I know from the table, I don't want to flip this board back over. I know from the table that f at 0 is -1. -1. So this is 1/3 times -1, which is -1/3. Now we got to solve for c. So we're going to add 1/3 both sides. Now 10 plus 1/3. I want you to get this in this at this level. Just write it as 10 1/3. 10 plus 1/3 is 10 1/3. 5 plus a half is 5.5, isn't it, right? Alright, so that's equal to C. Now, I got to go back to the original problem and put this in place of C right here. Alright, I got to say that. Now, so now, H at X is equal to 1/3 F at 3X plus C, which is 10 1/3. We're going to go ahead and write it. 10 times 3 is 30, plus 1 is 31. Since this is 1/3 here, we might as well just leave this as in terms of the, 3 in the denominator. Well, that's cool. Now, what are we looking for? I think what we're looking for is H of 2. I'm going to go down here one more time. H of 2 times 2. 3 times 2 is 6. Let's just now somewhere over here is 6. I don't know how far over I need to go. But when F at 6 is 5. So I know that F at 6 is 5. Alright. Actually, I had 2, 3 right here. And doesn't matter what these are. Okay. We don't care. F at 6 is 5. So H at 2 is what we're looking for. Keep in mind what we're looking for. 1/2 F at 6 plus 31 over 3. Real nice, because this is F at 6, which is 5 times 5. So H at 2, 5 times a half. See how I put that 1 over under the 5? So 5 times 1 is 5, 2 times 1 is 2, so 5 halves should be 1/3. Where are you getting 1/2 from, KP Math? Gee. Alright, everything's 3 here. I knew something was wrong. Alright. Now this is equal to 5 plus 1 is 6, so 36 over 3. And that's equal to, so H of 2 is equal to 12. Yeah, a lot, isn't it? It's a little shorter another way. I'm not going to say it's a whole lot, well, it may be a whole lot shorter, I don't know. But it is a little shorter. But this, sometimes, I'm just going to tell you from experience, I didn't look at how they did it. I don't like to do that. I like to figure it out on my own. And so I knew that when I saw on the other side that H prime at X is equal to F prime at 3 at X, and if I took that antiderivative of both sides, I would get H at X, because really I knew I needed H at 0 was 10, and I needed to find H at 2 anyway. Okay, so I changed H prime to H by just taking the antiderivative of that. And so that side is just H at X, and of course you got to remember to put your C here. If you don't, you missed your problem. So that's how I did it. That's the way I understood it. It makes sense to me. You still get the same answer, and it works. Sometimes problems are meant to be long. Sometimes they're meant to be short. But in this case, this is what we came up with here. Alright. And my thinking behind this one more time is, when we had that H prime at X equals F prime at 3X, I wanted to get down to h, and the only way to do that is to take the antiderivative of the derivative, and by the fundamental theorem of calculus, that just gives me f at h. And remember, this 3 is a 1/3. Just, you know, if it's been a 5, it's been a 1/5, right? Okay. And if I'd been 3/2, it's been 2/3. See that? Easy things to do. All right. You do have to be careful with the arithmetic, but if you are, you're going to get the correct answer. It's a good problem, really a good problem. And you had to go back and forth to the table, this table right here. Okay, you had to go back and forth to the table to figure it out. And so a whole lot of different skills are involved here. Okay, so anyway, KP the Math G, getting ready to sign off. Ladies and gentlemen, if you have not subscribed, please do so. I'd like for you to, but hey, if you don't, and this is all you wanted, okay, good enough. It's not about me, it's about you. I would like sometimes to see a comment, but if you don't have time for a comment, don't worry about it. It's alright. It's all good. If you're going to hit that like button, please do so, but if you don't, it's all good. Everything's good, isn't it? But it would be nice. I would like to see more subscribers, but it's not about me, it's about you. Alright, ladies and gentlemen, KP the Math G signing off. Ladies and gentlemen, have a great, great day. And I have to go feed the dogs now, and then feed myself.